Hello and welcome to the Daily Space for Wednesday, June 6th, 2018. I have to admit, I got a little bit distracted by the chat, and so we're a little bit late. Well, 1 minute late getting started. Yes, there's much discussion going on about what is NASA announcing tomorrow. At 2 p.m. Eastern, 1 p.m. Central, regarding the Mars Curiosity. I don't know. I'm desperately curious to find out as well. And we're going to bring it to you live here on CosmoQuest. And I'm going to sneeze. Okay. Sorry about that. It's apparently one of those days. So, yes, we are going to learn all about curiosity tomorrow. So we need to be a little bit patient. So the plan for tomorrow is going to be a little bit different than normal. And I'm going to spend a little bit of time updating you so you can free your calendars. Tomorrow, starting at our normal time, 1 p.m. Eastern, which is, doing math is hard, which is 6 p.m. London and 10 a.m. Pacific, we are going to come to you with the Daily Space. I'm going to do a quick roundup of anything that's new, and then I'm going to do an extended roundup of all the news we haven't had time to cover yet, coming from the American Astronomical Society. The goal is to stretch things out a little bit so that we can then transition into bringing you live coverage with commentary of NASA's press conference. So show up tomorrow, bring some popcorn or whatever you want to eat while watching the stream, and let's catch up together and find out what's going on that's so interesting that they're gathering the media together at NASA. Okay, so moving on to today's discoveries. As I've been talking about every day this week, it is the American Astronomical Society meeting out in Denver, Colorado. This is one of those opportunities for students to start presenting their research. In fact, this is a meeting that would lead one to believe that the astronomical community is filled with young people. It's actually not, but this meeting is. The best and brightest of all ages are usually given the opportunity to present their research and hopefully find a way to find their way into university and graduate school. This meeting is no different, and a group of students led by Dr. Jonathan Swift at the Thatcher Boarding School in California, have been using their campus observatory, which is newly refurbished, to study Tabby's star. This is a star with strange periodic dimming events that really aren't quite understood. One of the things the students did was they observed these dimming events in multiple wavelengths of light. And what they found was how much the star was dimmed is directly related to what color they're looking at, but not in the ways that would be expected if there was one kind of dust orbiting this star. And dust is one of the primary things that we think may be playing a role in these weird dimming events we keep seeing. What they think is happening, again, this is a group of high school students on their senior project, these are rising sophomores working with Dr. Jonathan Swift. What they think is happening is there are different kinds of dust, different thicknesses, different densities of dust at different distances away from the star. As these different clouds of dust orbit, we see different kinds of dimming events, and that may start to change how we look at this object as not necessarily appearing as it does in this NASA artist's rendering, but maybe this object is more like 838 Maaan, a star that we saw in the early 2000s give off flashes of light that illuminated these asymmetric disks, spheres of dust and gas around the star. Again, this is the kind of thing where only more observations are going to allow us to really understand what's going on. But this is a tantalizing hint of, well, explanations potentially to come. Now, continuing on through our research coming to us from the American Astronomical Society meeting, we have a press conference that was given by Dr. Timothy Beers. He is a chair of physics and astronomy at Notre Dame University, and I have to admit, he was my undergraduate academic advisor. Many moons later, he is still working on the same research that I learned about when I was a baby undergraduate. And he is looking to try and understand the most metal-poor stars that still exist in our universe. He and his research team have been looking at stars spectroscopically and trying to understand how all the different ratios of atoms that we see in these extraordinarily metal-poor objects came to be. In the latest research that they have come to present, they've been studying the chemistry of what our universe was like 10 billion years ago. What they are finding is there are a lot of stars out there, and some of them are as close as only 600 light years away here in our Milky Way galaxy. And these stars formed out of the early, essentially ashes, not actually ash, but the early spewed out material of dying massive stars that produced enormous amounts of carbon, nitrogen, and oxygen. These elements were then incorporated into that next generation of stars. What he's finding is these stars have very few of the kinds of elements that are produced in modern supernova remnants. And this is starting to give us hints of what the young galaxies that these stars were formed in may have been like. It's pointing to the idea that these earliest stars may have been formed in ultra-faint dwarf galaxies. And these galaxies merged, mixed together, and ended up forming the disk of our own Milky Way galaxy. This is why we're able to find these extraordinarily metal-poor stars here in our own Milky Way. This is complicated work. It actually started back in 1992. And every generation of stars, every new generation of telescopes is bringing us new insights on the chemical composition, the whereabouts, and just how many of these metal-poor stars are out there. So this is a story that isn't over, but this is one more data point in helping us understand how galaxies like our own Milky Way galaxy have come to form. Now, continuing to look at galaxies, and I promise you this is an image of a galaxy. Researchers are looking at dwarf spheroidal galaxies and dwarf irregular galaxies to try and understand what kinds of objects produce the heaviest of elements. There have long been two competing theories for the formation of elements like gold and silver and other, the metals that you may have forming the jewelry you are wearing right now. These two theories consisted of massive stars exploding as supernova. These are stars that they live and they die very quickly in only a matter of millions of years. And when they die, these materials would get recycled into the still forming smallest stars in their particular generation of objects. Now, the other competing theory, and both theories can be true just in different ratios, where there's very few supernovae and very many of this one more idea, which is that you have neutron stars and other heavy dead stars that are merging, colliding, however you choose to put it. They are, generating gravitational waves such as LIGO can now detect. And in this rather explosive new combination of objects, gold and silver and other heavy elements get released. By looking at dwarf spheroidal galaxies, what they've been able to find is that the dominant sources of these heavy elements, things that are formed through the rapid bombardment of neutrons onto the cores of atoms, these rapid process elements appear to form on relatively long timescales. This means they're generated over long periods of time in these galaxies. And these particular galaxies, these dwarf galaxies, well, most of their star formation formed all at once in the early days of this galaxy. If you have most of the stars forming early on, this means that most of the galaxies, most of this dwarf galaxies, supernova, would have also occurred early on in the galaxy's history. The only way that we can end up with elements like gold being formed in the long history of this galaxy over long periods of time is if the gold is getting formed in processes that spill out, well, in long periods of time. And the only way we know to get to that kind of a formation is to have these neutron star mergers dominate the formation of these heavy elements. So the story as we now understand it is you have a generation of star formation. Maybe there's one or two massive stars that live, that die, that give off heavy elements. But as the remainder of the stars live out their lives, some of them go on to form neutron stars, some of them in very special binaries form a pair of neutron stars. These neutron stars evolve over different amounts of time to eventually merge together. And when these mergers occur, this is when the heavy elements, the majority of the heavy elements, are released. So now, well, we understand one new thing in how the universe recycles. Now, what's kind of amazing to me about this is just in the late 90s and early 2000s, when we taught our students where did these elements come from. In fact, as recently as 2 years ago, when we taught our students where do these elements come from, what we said is they come from supernovae. And now it turns out we were simply oversimplifying the universe. Once again, the universe has showed us it is far more complicated than the human mind wants to understand. Now, coming back home to our own solar system. This week, with much fanfare and continuing press conferences related to his new book, Alan Stern has been talking about how the New Horizons spacecraft has once again turned itself on, coming out of hibernation mode, and is relaying data back and forth with the planet Earth. Thank you so much for hosting over, Uncle Bill. With the New Horizons spacecraft coming back online, it is in the process of preparing for a New Year's Day encounter with the rather unexcitedly named 2014 MU-69. Now, never one to miss a naming opportunity, Dr. Stern and his team have started referring to this object as Ultima Thule. And on New Year's Day here in the United States, so timing may vary across the world, thanks Ryan for the host over, with results varying across the world for exactly when this occurs, we are preparing for one more flyby of one more distant object. Now, they are describing this object as being the size of a large city, being reddish in color. We don't exactly know what shape to anticipate, but in preparing for the daily space, I had a bit of an epiphany. Neutron stars, like the ones that, well, appear to be forming so many heavy elements, neutron stars are the diameter of Manhattan Island, which is part of a large city. And this means that this object that New Horizons is going to fly by is, at least in size, not mass, in size, bigger than neutron stars. And that's kind of amazing to think about. What we're referring to as a fairly small Kuiper Belt object is bigger in diameter than these stars that we're seeing, generating gravitational waves capable of deforming our planet. Again, the universe is more amazing than we generally think about. Now, that brings to a close the news stories I have prepared for today. This has been your daily space for, June 6th, 2018. The Daily Space is brought to you by CosmoQuest X. Over at CosmoQuest.org, we offer opportunities for you to both learn and do science. We right now have a particular need of mapping data of Mars and Mercury. So if you have a spare moment, please go over to CosmoQuest.org and help us map out these two worlds that begin with the letter M. We also offer you chances to go out and map, the moon, because we like the letter M, and also Vesta and our own planet Earth. Now, CosmoQuest is brought to you by the Astronomical Society of the Pacific. We are a 501c3 nonprofit. Our goal is to put science in your head. So, to help sustain this show, give us a follow, show up, spread the word, get more people coming, get more people following, and we will show up to bring you science. After this show, we are going to transition at about 12:30 over to Dr. Matt Richardson, who is going to begin a new Astro 101 course to teach one of our programmers, Big J, who some of you may have seen programming on this channel, a little bit of planetary science and astrophysics. It takes all kinds to explore our universe. We need both the PhD astronomers to process the data in their final form, and we need the computer scientists, to allow us to figure out how to get the data from all the things that are run by software. Sometimes the programmers need to learn the science and the scientists need to learn the programming. And here at CosmoQuest, we're going to show you a little bit of both. So stay tuned for this new program that will start right after this one. But for now, I'm here to take your questions. So please go ahead at me in the chat, and I will see what I can do to bring you new information. So what questions do we have? I'm scrolling up through the chat. I see a lot of conversations going on, looking to see what information. Not seeing any questions right now. Let me scroll back to the bottom. Okay, so Larry is asking, you heard of the magnetorotational supernova that produced element with an R process in the early universe. How does magnetorotation do that? So magnetorotation is just one of those super complicated words that actually means there's a fast rotating object that is producing an extraordinarily strong magnetic field. So essentially we have big objects spinning rapidly, and when they go kapow, they spread material in all directions. Now, the exact details of this require modeling in something called magnetohydrodynamics. This is a force I am not strong in. So detailed understanding, I didn't prep that for today, and I have to admit I would have to go back and do some more reading to give you a deeper understanding. Astronomy requires people of all kinds, and my kind is the kind that uses a telescope and writes software, but not the kind of software that does magnetohydrodynamics. So I can look that up and try and answer it another day. Drop me the question in Slack so that I can hopefully remember. So Silent Searchlight is asking, the first story you covered about Tabby Star, is that similar to the discoveries made in observations of Epsilon Aurigae? So let me pull that image back up. Epsilon Aurigae is a variable star that was studied in great detail back in 2009 when it went through one of its extraordinarily strange dimming events. Epsilon Aurigae is a star that we see getting dimmer, 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 bright, dim, brighter, 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 brighter. And for a long time, because this is an event that only occurs every many years, it was known that it occurred, but it wasn't entirely known why it occurred. The dominant theory that there was some sort of a companion object, whether it be a tiny star or a giant planet, that was surrounded by a disk of gas and dust. And it was that disk that was doing the primary dimming event. And then the hole in the disk, cleared out around that central object, would allow a rebrightening of the star. This was in fact confirmed during the 2009 observations. So this is a fairly straightforward system that just was annoying to observe because it, went through eclipses so rarely. And digital detectors are so new. We now understand it, we think. And, it will be another while before we have further confirmation, but we think we're good. With Tabby's star, we don't have periodic dimming events. And this lack of periodic dimming leads us to believe there may be some sort of a splotchy something, either clouds of comets, sporadic clouds of dust and gas, or even perhaps an alien megastructure that is located around this object. And it's because of the patchiness in whatever it is that is around this object that we see non-periodic patchy dimming. The new understanding that these high school students appear to be bringing us is that there might be multiple parts to this gas and dust that have different compositions, different size molecules, and are at different distances from the star. So this is a different object, a completely different object. This is an actual object. This is the variable star 838 Maaan, and it underwent a flash of brightening back in the early 2000s. I believe it was back in 2002 that this occurred. And these brightening events lit up the dust around this star. And we can see in this image for the first time just, how patchy the distribution of dust and gas around a star can be. It's possible that it's this kind of patchy structure that might be located around Tabby's star. Now, this is me as a variable star astronomer reading these results. This direct comparison was not made in the press release, and in fact, I'm probably going to be emailing the advisor of these students later today to say, hey, have you thought about and maybe modeled this? So going back to the chat to see what other questions you have. Yes, Silent Searchlight, it is every 27 years. I couldn't remember exactly how many years. I just knew the last time it dimmed was prior to the advent of digital detectors. Insert History Channel aliens meme. Yeah, that is in fact a thing. Yes, that is a thing. So Silent Searchlight, yes, fair enough. Virtually nothing in common with Epsilon Rigi. Well, it's in common that things have dust and gas in weird formations, and the other way to stump an astronomer, other than asking things involving magnetic fields and magnetohydrodynamics, is to ask them, how might dust affect this? I'm a little bit better about answering about the dust. So Beebs123NJ is saying, if in the future we have access to essentially infinite energy, would a Hohmann transfer orbit still be used? I think it depends on what you're trying to do. One of the more intriguing ideas I've seen in science fiction was in, I believe it was one of Kim Stanley Robinson's books, where they imagined a future where there are asteroids hollowed out and moved into, essentially Hohmann transfer orbits. And people can, for lower cost than a direct flight, hop a ride inside an asteroid. And in this fantasy future, they spin up these asteroids. So each asteroid, again, hollowed out, has on its inside, along the equator of this rotation, a different kind of climate. So they imagine some of the asteroids you can hop a ride in have Arctic environments. Others have perhaps prairie environments. And inside each of these different asteroids, they have essentially a nose arc for one typical kind of, well, biosphere that exists on our own planet, in hopes of someday being able to repopulate our currently slightly environmentally broken world with the rarest of animals. I just love this picture of the future and this idea of filling the home and transfer orbits between all the different planets with this, well, way of getting around our solar system inside asteroids. So I don't know if it will happen. None of us can know what the future brings. But this is one particularly fun to think about potential future. Yes, asteroids could host backup of genetic material. There's actually been discussion about putting a seed bank and genetic cells bank up on the moon as protection. So there's lots of different ways to imagine protecting Earth's life. Thank you so much for the follow, Farah Bamoni. I have no clue if I said your name right, but thank you, however you say your rather cool username. So Hanny is saying, when black holes form in a solar system, are all the planets lost? The black hole should still have a lot of the original mass. So the kinds of objects that end up forming black holes have the capacity to have planets around them. Now, the question is, as they undergo massive amounts of mass loss, you have stars that may start with dozens of times the mass of our sun that undergo so much mass loss that by the time they go supernova, they're just, well, a ghost of their former selves, and they leave behind only a three solar mass black hole. With the massive amounts of mass loss, with the supernova event itself, it is possible that many of the planets, well, become lost in space as they spiral away, get pushed away, as all sorts of different things cause them to lose their gravitational hold on that object they used to orbit. Now, this isn't to say that we won't have fragments left behind. The very first planets that were ever discovered were discovered around neutron stars. The dead embers left behind in one kind of massive star supernovae. Now, these objects, they weren't anything like our own planet or even like things like Mercury. Rather, these were tiny fragments. So it could be this is a highly disruptive process, and it can also be that the supernova explosion itself and its shock waves are capable of shocking things into forming new objects. We don't entirely know, and anyone who tries to tell you they fully understand how solar systems are formed is lying. This is something that the more we see about our own universe, the more we realize we really don't fully understand, or even mostly understand, how solar systems and the planets they contain come to exist in all the ways they exist. Yes, Silent Searchlight, it is entirely possible that a planet becomes a planetoid, or I like the way you put it, a planismo. Yeah. Okay, scrolling back through the chat. So Pharaoh is saying, I'm an architecture student. I don't know much about space. If a random individual wants to get into it, what book would you recommend? There's new books coming out all the time, and it's hard to say where to start. I can recommend our podcast, Astronomy Cast, is a good podcast to start with. But in terms of books, Timothy Ferris is one of the most poetic writers out there. Grab whatever his latest book may be. It will be fascinating no matter what it is. Dava Sobel is another amazing author. She just wrote a book about the women that worked at Harvard College Observatory to help us define some of the fundamental astronomy that we use to understand stars and the expansion of the universe. Larry Susskind is a modern cosmologist. He's also a very good writer. And the reason I'm recommending authors is because they come out with books on a regular basis that talk about our changing understanding. My favorite book is Coming of Age in the Milky Way, which came out in like 87, 88. And the cosmology in that book, the modern cosmology in that book, is totally wrong. Anything you read that was published prior to 1999 is obsolete. In some ways, anything you read that was published prior to 2015 is completely obsolete. Our understanding of astronomy is advancing amazingly rapidly. So it's kind of hard to figure out exactly where to start. Other good authors are David Grinspoon. I have to say, though, my personal favorites are Susskind, Dava Sobel, and Timothy Ferris. They're all very, very different and my favorites. Looking to see what else there is. So it is time for me to transition this show. I'm sorry, guys, I'm running late. I'm going to shut down this stream, but don't go away, because starting in just a moment, Dr. Matthew Richardson is going to be coming to you with Astro 101 and his personal pupil, Big J. Big J is one of our programmers here at CosmoQuest, and he needs to learn astronomy. Thank you, Keeper of Maps, for the random amount of bits. I love random bits. So stay tuned, and you too can learn along with Big J exactly how it is we know what we know about the solar system and the universe beyond that we all share. Once again, this has been the Daily Space. I am Dr. Pamela Gay. This is part of CosmoQuest. Visit cosmoquest.org and be part of learning and doing astronomy. We are brought to you by the Astronomical Society of the Pacific in collaboration with a number of partners. Dr. Matt Richardson is a scientist over at the Planetary Science Institute. We're also working with Youngstown State University and a myriad of other partners. So all of your subscriptions, all of your bits, they all help us sustain what we do. Thank you, Chupan, for 45 random bits. And now I'm going to hand things over to Matt Richardson, Dr. Matt Richardson, and his pupil, Big J. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember, sometimes you need to look up. Bye-bye.